Hello students, how are you all? I hope you are doing well. So let's come to the live one by one, and if you want to discuss something with me, then you have to first of all subscribe to our channel. Only subscribers can talk in the live chat. So if you have not yet subscribed, please don't forget to subscribe to our channel. Now today I am going to discuss a very important and requested topic by all of you, circuit theory. Basically KCL and KVL related numerical questions. Hi Austin, welcome. So as I have told you many days before, circuit theory, KCL and KVL, many students struggle solving questions based on circuit theory. So today I am going to discuss questions from your KCET, from your PU2. So both aspect will be covered. If you are someone who is weak in how to apply KCL, KVL in little complicated circuits and you are losing marks there, then worry not. I will help you to solve those questions. I have taken handpicked some questions from your model papers, from your PYQs, and also from your KCET PYQs as well. So let's start our session. First we will start with Kirchhoff's rules. There are some says Kirchhoff, some says Kirchhoff, both are okay. Kirchhoff Indian pronunciation, Kirchhoff international pronunciation, both are good. Now there are two rules, there are two Kirchhoff's rules. First of all, junction rule. At any junction, the sum of currents entering the junction is equal to the sum of current leaving the junction, and this is a consequence of conservation of charge principle. Let me explain in a bit. Suppose we have a complicated circuit and you are looking at a junction. Junction sometimes is also called node. Suppose we have a junction. Junction means where multiple currents meet at a point. Okay, this is called junction. So here suppose a incoming current is coming from this side, it is meeting over here. Another incoming current is coming from there, meeting over here. Another current is coming from this side, and again they are all meeting. So they are all meeting over here. So I1, I2 and I3, they are all meeting over here, and consequently some currents are leaving the junction as well. So whatever is incoming, there has to be some outgoing. Suppose only two currents are leaving the junction. Okay, so suppose I4 and I5 are leaving. Okay, so what is Kirchhoff's current rule? Current rule says that whatever current which is coming into the circuit, that is sum of I1 plus I2 plus I3, and whatever current is exiting, that is I4 plus I5, that should be equal. So whatever current is coming in, that same current should go out. Now we say this is a conservation of charge. Now you might think many students actually confuse why it is involved in conservation of charge. So suppose we take some time t. So what is the total charge that is going in? Total charge that is going in is given by this entire current divided by time t, and what current is going out? Going out is, again, if you multiply by t, then you will get the current. Now what is I1? I1 is Q1 by t plus I2 is Q2 by t and I3 is Q3 by t. Right? So if you multiply and if you simplify, you will see that basically Kirchhoff's law is talking about the charges that is coming in and the charges that is going out must be the same. You can consider this to be an isolated system, and in an isolated system, total charge has to be constant. So charge that is coming in is this, and charge that is going out is this. So that's why, because the charge that is coming in is equals to that charge is going out, it is basically based on conservation of charge. Okay, now next law is Kirchhoff's voltage law, KVL. The algebraic sum of changes in potential around any closed loop involving resistors and cell in a loop is 0. So what is the meaning of that? Suppose we have a complicated circuit. Again, we are taking a part of a complicated circuit where a cell is involved, there is some internal resistance of the cell, and obviously some current is passing. So suppose the current in this is I, current through this, say I dash. Now according to Kirchhoff's law, it says that if you take any closed loop IR, this is say V and this is say small r, then IR plus I dash R minus V should be equals to 0. Okay, now I generally do not recommend to remember the formula like this. I recommend that you should remember the formula not like this but equals to V. Okay, this is the easiest way to remember the Kirchhoff's law. Okay, so if you take voltage on the other side, it will be negative, but if you know how to apply Kirchhoff's law, then this should be the structure. Now there are few things you should know on how to apply KVL. So first of all, whenever you are considering, you have to consider a loop. What is the meaning of a loop? A, B, C, D. A loop is something that when you start your journey, during your entire journey you have to move in a single direction. That is very, very important. Okay. Secondly, when you are moving, say A to B, B to C, C to D and D to A, your starting point and your ending point should be same. So you have to maintain the direction of the journey, and you also have to maintain that starting point and ending point has to be same. That is called a loop. Now in a circuit there can be multiple loops. Okay. We will take some examples, but in a circuit there can be multiple number of loops. You have to be careful that the loop that you are choosing is simple enough. Okay, for your class 12th or PU board, loops are simple. You should not take complicated loops. You should try to avoid complicated loops as much as possible. Okay, simplest loop. And also my recommendation is that you start with the battery, polarity of the battery. This is the easiest way to remember. You start with the polarity of the battery. So battery has a positive and a negative, right? And you choose your direction of the loop such a way that you are going in a direction where this battery is trying to send the current. Now in some cases there may be more than one battery and you may need to choose accordingly. And you also have to remember each and every loop is independent from another. Each and every loop is independent from another when you are applying KVL. Okay, first KCL, first stage is to apply KCL, find the currents. Okay, imaginary currents, does not matter. You have to take a direction of current. You don't know the direction of current, that is fine. You take the direction of current on your own. The calculation itself will take care whether it is positive or negative. Negative current represents the current is actually in the opposite direction. Suppose after solving a complicated equation you found that value of I is -2. So that means you have taken the direction of current in this direction, but in reality current is flowing in the opposite direction. No harm in that, no harm in there obviously, but as long as you are calculating it properly, you should be fine. Now I recommend, what are my recommendation? First is you always choose the direction of the battery as your direction of your loop. So for example, I have taken A, B, C, D, A. So in this case the current is flowing from A to B, B to C, C to D. That is the direction of the current. Now there are few rules that you have to remember. What are all those rules? The current that is exiting a battery, has to come back to the battery. Okay, so if a resistance is connected directly with the battery, okay, if a resistance is directly connected with the battery and if the current that is coming out of the battery is given by I, then that current should also pass through this resistance. Okay, it can be different in different branches, but as long as battery is concerned, whatever current is exiting the battery, the same current has to go back to the battery. This is also due to the conservation of charge. Okay, so this is one important thing. So if I dash current is going out of the battery, a new current, say I double dash, will not be coming back to the battery. If I dash current is exiting the battery, same amount of current should come back to the battery, no matter what is the polarity. Even if the battery is reversed and you are getting the current in the opposite direction, does not matter. Current in the battery should always be conserved. So the entering current should be equals to the exiting current. That is a rule. That is not a recommendation, that is a rule. Okay, and for each resistor you have to apply Ohm's law. Okay, for each and every resistor you have to apply Ohm's law. If you are going in the direction of current, everything will be positive. If you are going in the opposite direction of the current, everything will be negative. Now let's Kirchhoff's voltage rule, by the way, is based on conservation of energy. So I square R, if you take I square R, if you add all the I square R, you will be getting the total energy. So conservation of energy principle gives you the Kirchhoff's voltage law or loop rule. Okay, loop rule is the term that is given in your NCERT textbook, and in your KCET also they will use this form, but KVL is used in some of the reference books and in some international books as well. When we studied, KVL, KCL was the term, but nowadays they have changed it to junction rule and loop rule for more adaptability. Now let's see one question. Okay, hi Sanika, good evening. Good evening. So now let's see one question, one simple. We will start with a simple question. A current 6 ampere enters one corner P of an equilateral triangle PQR, okay, having 3 wires of resistance 2 ohm each. So we can see that 6 ampere current is entering this junction. This is a junction, okay. This is an example of a junction, and we have a equilateral triangle. Each side has resistance 2 ohm, 2 ohm, 2 ohm. Okay, and leaves by the corner R. So it is entering from corner P and it is leaving by the corner R. Okay, then the current I1 and I2 are. So you have to find the current I1 and I2. So this is a very simple question. Many of you may be thinking how it is a simple question. First of all, we will apply Kirchhoff's current law. So first stage is to apply Kirchhoff's current law. So what is that? 6 ampere current is coming in and 2 currents are going out. That means I1 plus I2, that is outgoing current, must be equals to incoming current. So I1 plus I2 must be equals to 6. So this is our first stage. Second stage is, if we can apply any law of resistances, that is parallel combination, series combination, if possible, okay, then we will try to simplify the circuit. In this case it is possible, not every case it is possible. So we will see if anything, any combination of resistance is possible or not. So here if you see that we have a 2 ohm, we have a 2 ohm, in between there is nothing, no other voltage source, no other current cell or no other current is coming in. That means these two are actually connected in series. These two resistances are connected in series. So 6 ampere, that 6 ampere goes in, okay, and I1 actually passing through 2 ohm resistances. They are in series. That means we can consider them as a total of 4 ohm. Okay, 4 ohm current passing through this 4 ohm is I1, right? Both of them, both of the resistors having same current means obviously series combination. The remaining I2 current is passing through this 2 ohm, which is actually connected in parallel. Okay, so this 2 ohm actually carrying a current I2. Now for this particular case we are not applying KVL, but we are applying a concept of parallel combination. What is that? The voltage drop across parallel combination must remain constant. The voltage drop across parallel combination must remain constant. That is, suppose the voltage drop between both of the resistor is V, then V must be equals to I1 into 4, that is 4 I1 for this resistor, and 2 into I2 for this resistance. Both of them should be equals to this constant voltage V, because they are connected in parallel combination. So we are getting a relationship between I1 and I2. Okay, so 2I1 equals to I2. So we got a relationship between I1 and I2. Also from Kirchhoff's current law, we know I1 plus I2 must be equals to 6. So we will put the value of I2 in this equation, that is 2I1. So 2I1 equals to 6, or 3I1 equals to 6, or I1 equals to 2 ampere. So step by step process. First, Kirchhoff's current law. Simplify the circuit if it is possible. Once simplification is done, now see whether it is a parallel combination or series combination. In this case they are parallel combination. So parallel combination means, in parallel combination we know that voltage is constant. So constant voltage means voltage, this constant voltage should be applied across this resistance as well as this resistance. Okay, so 2I1 equals to I2, and now if you put the values, you get I1 equals to 2 ampere, and what will be the value of I2? I2 will be equals to 2 into 2, that is 4 ampere. Okay, so you can calculate this I1 and I2 from this given circuit. Okay, now it can come as a form of MCQ, where they will ask that what is the value of I1. So in that case you just simplify and find I1. If they ask you what is the value of I2, then you simplify directly into I2. In that case you have to substitute I1 equals to I2 by 2, so that you can directly get the value of I2. Okay, so based on the question, based on the option, you have to adapt. Easy question. This is a KCET question. Now we will be solving one more question. Okay, in the following network the potential at O is. So here also we will be seeing basically application of Ohm's law, as well as some concept of current, Kirchhoff's current law. Okay, KVL we have not yet came. So first of all they have given you this circuit, and they asked you what is the voltage at this point O. So we will assume that voltage at this point O is V. Voltage at this point is V. What else? Voltage at these two points and this point are given. Resistances are also given. Now whenever you are considering a particular segment, suppose we are considering the segment AO. Okay, so in that segment what is the voltage drop? The voltage drop is current must be passing from higher voltage to lower voltage. These 2 points have lower voltage. That means current should pass from higher voltage to lower voltage. So V must be intermediate between these two. So V is a lower voltage point. So for the segment AO, we will apply Ohm's law. First stage Ohm's law. And we will see that this point has a voltage V, this point has a voltage 8. So what is the voltage difference? 8 minus V. 8 minus V is the voltage difference. What is the voltage resistance between these 2 points? Resistance is 2. So that must be the current I. Okay, so current I flowing through this area is given by this formula. Okay, now there will be current I1 through this and current I2 through this. Okay, from Kirchhoff's law we can say that I must be equals to I1 plus I2. So if we can calculate I1 and I2, and if we can add all of them, then we can compare them and we can find the value of V. So let's calculate I1. So I1 will be, now this is higher voltage, this is lower voltage. Current is flowing in this direction. So V minus 4 divided by the resistance 4 must be equals to I1. And for this junction, V minus 2 divided by 2 must be equals to I2. So this is the standard procedure. If you know the voltage, intermediate voltage, you can find the currents. Now we will say that I must be equals to I1 plus I2, and we will put these values. 8 minus V by 2 equals to V minus 4 by 4 plus V minus 2 by 2. Now common LCM is 4, so multiply everything with 4. Multiply everything with 4 and we get 4 into 8 minus V by 2 equals to 4 into V minus 4 by 4 plus 4 into V minus 2 by 2. Okay, so this cancels, we get 2 8 is 16, 2V is 2V equals to 4 cancels, so V minus 4, and we get again here also 2 cancels, we get 2V minus 4. Okay, so we get 16 minus 2V equals to 3V minus 8. Now exchange the terms, we get 3V plus 2V equals to 16 plus 8. That is 5V equals to 24, or V equals to 24 by 5, that is 4.8 volt. So the intermediate voltage is 4.8 volt, and this is an MCQ, so correct answer is option D. Now we will not only solve MCQ, we will be solving some numerical questions as well, so don't worry, we will be solving numerical question. The next question is from your PU board model question paper, right? This question is latest model paper, and if you see that there are 2 cells given in this circuit. Okay, and they said that calculate the power dissipated in 10 ohm resistor. So this is a 10 ohm resistor. They asked you what will be the power dissipated in this circuit. For this we will be, today I will be using Kirchhoff's laws. Tomorrow there is a Brahmastra on the chapter current electricity. There also I will be solving it, but using a different method. So you can decide which method is better for you and you can choose it. Okay, Kirchhoff's voltage laws are simple. So if we say that current through this is say I1, current through this say I2, then the current through this is I1, this is I2. So total current passing through this is say I. Then from Kirchhoff's current law, we can say that I must be equals to I1 plus I2. And we are trying to find the power dissipated in this 10 ohm. That means power dissipated must be equals to I square R. So if we can somehow find this current I, we can find the power dissipated. Now what we have to do? This, if you see that they are electric cells having internal resistances. If there was no internal resistance, this would have been an easy calculation. But because we have internal resistances, we have to take loops. First we will consider the loop this 1 1 2 3 4. So this loop we will consider first, 1 2 3 4 1. Okay, so for 1 2 3 4 1 loop, 1 2 3 4 1 loop. Okay, you can name it using ABCD, you can name it using 1 2 3 4, does not matter. So from this loop we can say that what is the current through this going out is I1. That means, as I mentioned, current that is coming in should also be I1, and the current through this internal resistance which is given here as 1 ohm, that 1 ohm, through that 1 ohm will also be I1. Current through this resistance is given by I, so we will put that. So 10I plus, we are every time whenever we started from here, we are going in the direction of current, no deviation here. That means it will be plus 1 into I1. Resistance is 1, so 1 into I1 must be equals to the EMF of the battery, because we are going in the direction of the battery where the battery is trying to send the current. So if the battery is trying to send the current, if you are going in that direction, then on the right hand side of your equation you should use positive of the EMF. Okay, now what is the value of I is I1 plus I2 plus I1 equals to 2, or 10 plus 1 11 I1, 11 I1 plus 10 I2 equals to 2, right? So if you face any doubts while watching this, you can do mention that in the comments. Sir, I did not understand that. I will try to explain that again. If you have any doubts, please mention in the comment. So 11I1 plus 10I2 equals to 2. Okay, now what? So now this is our equation number 1. This part is done. Next we will apply again same principle in the second loop. Second loop, we can take second loop this one or this one. So if you take this route, this will be a complicated part. Okay, we will not take a route where two batteries are involved unless and until it is absolutely necessary. In this case, it is absolutely not necessary. So we will take the route where we have to use, we can use a different path. So we will use 2, 3, 5, 6. 2, 3, 5, 6. This direction we will take, and as you can see here also we are going in the direction of the current, and also we are going in the direction where the battery is trying to send the current. So 2, 3, 5, 6, 2. So this is our second loop. And if you consider this, again we will see that we are going in the direction of current, and as I said, the I2 current is exiting the battery. That means I2 current should also come back to the battery, and the resistance here given as 2 ohm, that will also have this I2 current. So 10I plus 2I2 equals to 4. Okay, from this loop we are getting 10I1. 10I1 is same, but I2 is different here. Now we will put the value of I again. I1 plus I2 plus 2I2 equals to 4. Now what smart work we will do, we will see that each term is a multiple of 2. Each term is multiple of 2. So we will divide each term with 2. So we get 5I1 plus I2. This one you can do based on the problem and based on the question itself. So 5I1 plus I2 equals to 2. So 5I1 plus 5I2 plus I2 equals to 2. Now add the similar terms. You get 5I1 plus 6I2 equals to 2. This is our equation number 2. Now two variables, two equations, we have to solve them. First stage we will be simplifying for I1, second stage we will be simplifying for I2. So how to simplify for I1? We have to multiply this equation with 11 and this equation with 5. So multiplying equation number 2 with 11 and then subtracting it with equation number 1 after multiplying it with 5. So 11 into 5 is 55I1 plus 6 into 11 66 I2, and then 2 into 11 22. Okay, and multiplying first equation with 5, we got 55I1 plus 50I2 equals to 5 into 2 is 10. So if we subtract these two, I1 will be cancelled. Now if you see that 16I2 equals to 12. Now we can calculate I2. So from here we can say that I2 equals to 12 by 16, that is 3 by 4. So 3 by 4 is the current I2. Now we will use this value of current in this equation, or you can use this in this equation, any one of the equations, and calculate I1. So we will be using equation number 2. So 5I1 plus 6 into 3 by 4 equals to 2. Now 5I1 2 3, that is plus 9 by 2 equals to 2. So we got 5I1 plus 4.5 equals to 2, or 5 I1 equals to 2 minus 4.5, that is minus 2.5. So as I mentioned, so I1's direction is actually not in this direction but in the opposite direction. It does not matter, no matter whatever direction you have taken, as long as you are doing a correct calculation, the sign will automatically come. So initially you have to take a direction according to your understanding and according to the simplification, how much simplification you can do. But ultimately it will come as you are solving it. So I1 is minus 0.5, I2 is 0.75. Okay, 3 by 4 means 0.75. So what is the current? Total current must be minus 0.5 plus 0.75, that is 0.25 ampere. This is the total current in the circuit. So what is the power dissipated in the circuit? Power dissipated in the circuit must be 0.25 square into resistance is 10. So it will be 0.0625 into 10, that is 0.625 watt. Okay, there is one more method, slightly easier than this, that I have done in the Brahmastra, coming tomorrow. You can go and check that out. Okay, now next problem is this one. In the electrical network shown in the figure, calculate the power consumed by the resistance of resistance 4 ohm. Okay, so we have to calculate the power consumed by this 4 ohm. So if you see this circuit, this is almost similar circuit, only difference being that this battery does not have any resistance. Okay, this battery has a resistance, this battery does not have any resistance. So power consumed is going to be easier calculation, but I will not solve it. I will give you this as a homework. So please take a screenshot, and whenever you are watching this video, does not matter you are watching this live or not, try to solve this problem and mention the solution in the main comment. Once the live is over, you mention the answer in the main comment. If you are watching this live and if you are solving it right now, you can mention the answer in the live chat as well. So what is the method? I1 is given over here, I2 is given over here, and as you can see, I1 plus I2 is given over here as well. So like the previous problem, everything will be same. You will take this loop once and you will take this loop once. But in this case there is no internal resistance, that means I2 can be calculated easily. Okay, in fact I2 will be 6 by 4. So that is one thing, I2 will be 6 by 4, but I2 will not be 6 by 4, but you have to calculate it. Anyway, there is no internal resistance, that means this is an easy calculation. Okay, and if you know the current, then you can find the power as well. Power is given by I square R. Okay, I is this one, right? Now next is Wheatstone bridge. Wheatstone bridge is the one of the most important and most difficult concept. Many students struggle in there, and some students are asking, sir, please solve Wheatstone bridge for unbalanced condition. That also I am going to do in today's lecture. So but first of all, you have to understand the condition of balanced Wheatstone bridge and what is the meaning of balanced Wheatstone bridge means. So this is a Wheatstone bridge. As you can see, there are 4 resistances in the Wheatstone bridge. Okay, it acts like a bridge, that's why it is called bridge, and Wheatstone is the name of the person who developed this circuit. It was very popular. Even today also it is very popular when you try to measure any unknown resistances. Okay, and it is a mechanical process through which you can measure unknown resistances. When back in the day, when no telephone was there and we are sending messages using telegrams actually use this device to measure the resistances. Like today we have a fixed mobile number or phone number. Okay, when telegram system was used, every place, every city used to have a different resistance. Okay, and if you are not sure that resistance that you are using in the circuit is different, then you will, instead of sending a message to Delhi, you might send the message to, say, London. So that's why the exact value of the resistance was very necessitated, and there was something called a post office box, which was actually based on this Wheatstone bridge principle. Okay, it was in your syllabus a few years back, but after the syllabus was revised, and because post office boxes are no longer being used in practicality, it was deleted. Okay, but Wheatstone bridge is very handy concept. So as you can see, in balanced condition, the current through the galvanometer must be equals to 0. Okay, this is called the balanced condition. So in the circuit you will have a galvanometer, and you will adjust this resistance R such that the galvanometer slowly becomes balanced. So as soon as you see that galvanometer is balanced, that means the bridge is balanced, and if the bridge is balanced, no current coming in this way, that means whatever current is going through P, the same current should go through Q as well. So this will also be I1. Similarly, when the bridge is balanced, whatever current is passing through S, the same current should pass through R as well. Okay, so this is how you should consider the Wheatstone bridge, and the condition for balance is P upon Q equals to R upon S. There is small mistake, it should be R over here and S over there. Okay, okay, R should be here and S should be there. So R upon S. So this is the condition of balance. You can say that P by R equals to Q by S. That is also a balanced condition. P upon Q, R by S. So any opposite resistance, if you take the ratio of any opposite resistances, it will always be same. So P upon R equals to Q upon S, or P upon Q equals to R upon S. Okay. Now let's solve one question. This is from your KCET 2024. Okay, this question came in KCET 2024. Okay, 2 years back. Right, now try to solve this. So this is a circuit. If you understand this circuit is actually nothing but a Wheatstone bridge. So how I say that? So this pattern is very common across JEE, across NEET, across KCET as well. Okay, this pattern is actually a Wheatstone bridge pattern. Now if you draw this circuit a little bit different, such that this resistance is rotated like this, and this point goes up, then this resistance starts here, and this is going over there. This resistance starts here, this is the common point I have taken up, right? So and this resistance goes somewhere there. Okay, and this resistance, second resistance, starts here and ends at the second end of the resistance. So this is the second end. Okay, similarly this resistance starts at the end point and it meets with the first resistance. So this is basically nothing but our Wheatstone bridge. So this circuit and this circuit are same. This is a way to draw Wheatstone bridge. So if you are aware that this is a Wheatstone bridge, any Wheatstone bridge related questions you can solve. Okay, and in this case the condition of balance that we will consider is this resistance divided by this resistance, if it is equal to this resistance by this resistance or not. So as you can see here, R by R is 1, and here also R by R is equals to 1. So the Wheatstone bridge is balanced. Now what is the most important point if the Wheatstone bridge is balanced or not? So if the Wheatstone bridge is balanced, we can say that this galvanometer resistance is no longer needed. Just give me a second. So if this Wheatstone bridge is no longer needed, this galvanometer is no longer needed, then what we can do, we can simply erase it. So no current is passing through this galvanometer means this is actually a distraction. So we need to remove the distraction and we have to look into the circuit. Okay. So if no current is passing through this galvanometer, we have removed the galvanometer. Now you see that this one and this one, they are actually connected in series, and this one and this one, they are connected in series. So these two resistances in series, these two resistances in series, and their combination is actually connected in parallel. So this is how you should treat any Wheatstone bridge related problem. Okay, now what we will be doing here, I will try to simplify this. So if you watch this circuit carefully, you will realize that in this case, this is the galvanometer and no current is passed through this galvanometer. That means this is a distraction. We will simply erase this resistance. Okay, and if we erase this resistance, then the circuit becomes clear to you. So as you can see, this and this are connected in series, this and this are connected in series, and they are connected in parallel mutually. Okay, so what is the equivalent resistance of these two? Is R plus R, that is 2R, and this is also R plus R, that is another 2R, and 2R and 2R in parallel, two equal resistances in parallel. So two equal resistances in parallel means their equivalent resistance will be just half of that, that will be only R. Now there is one important shortcut that you can remember from here. If all the resistors in a Wheatstone bridge or in circuit like this are same, if all the resistors are same, their equivalent resistance will be equals to any one of them. Okay, so this entire combination of all R's is basically a single R. So now we have a single R as our resistance. Now if you see this end also we have another Wheatstone bridge, and this Wheatstone bridge is also balanced. As we can see, 2R by 2R equals to 2R by 2R. So definitely through the center galvanometer no current is being passed. That means this is a distraction. We can simply erase this as well, and because we have erased it, that means this is no longer part of the circuit, as no current is passing through this area, through this resistor. Now again, if you see that all the resistances of the second Wheatstone bridge is also same. So if the resistance of all the second resistance is same, then what will be the equivalent resistance of this one? The equivalent resistance will be 2R. Okay, this one is all the resistors are 2R. That means its equivalent resistance will be 2R as well. So if all the resistances are same, equivalent resistance is equal to the value of only one single resistance. Okay, so one end is connected with the voltage supply VO, other end is connected with grounded. That means the voltage is 0 over here. So what is the current through the circuit? Current through the circuit must be V0 minus 0 divided by R plus 2R. They are in series, so that means V0 by 3R. So correct answer is V0 by 3R, option D. Okay, Sagar Anmol Chopra is saying by. So if you are saying by, why you came over here, right? If you have any doubt, please mention it. Whenever I try to teach you circuit theory, you said, sir, I don't know circuit theory, please teach us. Now when I am teaching, he is coming and saying by, which is not good, right? Unless you are expert in circuit theory, you have solved all the questions in circuit theory. Otherwise you have to attend this session. Now next is another Wheatstone bridge type of problem. As you can see here also, we have a Wheatstone bridge 3648, and instead of giving a galvanometer, they have given you a center resistance. The first test that we should do, whether this bridge is balanced or not. So how to check the balance condition? P by Q equals to R by S or not. So what is P by Q? P by Q here is 3 upon 4. So this is P by Q. What about R by S? So R by S is given by, so R by S is given by 8 upon 6. R by S is given by 8 upon 6, right? So 8 upon 6 means, sorry, not 8 upon 6, it is 6 upon 8. Okay. So it will be R by S, that is 6 upon 8, 8, which is 3 by 4. So P by Q and R by S condition is satisfied. So if you are still confused, this is P, this is Q, this is R, this is S. So that means again this is a balanced bridge. So balanced bridge means this central resistance we can simply erase. No current is passing through this resistance. That means we can simply erase this resistance, and we just need to calculate the equivalent resistance of the remaining portion. Okay. So what is the equivalent resistance of this portion? So 3 and 4 are in series. 3 and 4 are in series, so equivalent resistance of that is 3 plus 4, that is 7. And 6 and 8 are in series, so that will be again 6 plus 8, that is 14. So 7 and 14 are in parallel. So what is the equivalent resistance? Equivalent resistance is 7 into 14 divided by 7 plus 14, that is 7 into 14 divided by 21, so it will be 3, so it will be 14 by 3. So 14 by 3 is the equivalent resistance of this case. Now if you observe that in this particular case, Sagar is saying it's my typing error, sorry sir. Okay, no problem. I thought you were saying by, but okay, you are saying high. Okay, understood. So now now what is this is in this particular case all the resistors are different, that's why the equivalent resistance is different. Okay, if all the resistances were same, suppose everything is 3 3 3 3, then after doing all the exercise you would have got 3 only, so you don't need to calculate that, you just directly write 3. But in this case, because circuit is balanced and resistances are different, then you have to calculate it, and answer is 14 by 3. Okay, so just you have to be careful a little bit, and the step for solving any Wheatstone bridge related questions, check this. Check you can do visually as well. 3 by 4, 6 by 8. 6 by 8 is also 3 by 4. That means circuit is balanced. Remove the circuit. These two are in series. 4 plus 3 7. 6 plus 8 is 14. And what is the equivalent resistance of 7 and 14? 7 and 14. This is the formula for parallel combination, and you can calculate it directly. Okay. Now this question came in PU 2024 exam. Unbalanced Wheatstone bridge. This is the one of the most difficult question in the PU calculation. I have taken it from PU board paper, slightly dotted. A clear image was not available in the website, but whatever image I could download, it is there. Now if you see that in the problem, they have already mentioned the currents directly: I1, I2, IG, I1 minus IG, and I2 plus IG. So they have mentioned the current directly. So Kirchhoff's current law portion that you have to do at the beginning, you don't need to do it. That is already being done here. Okay, if the problem is complicated, remember this, if the circuit problem is complicated, mostly they will always give you the Kirchhoff's current law part covered in the diagram itself. Okay, so if it is given in the diagram itself, you don't need to do the Kirchhoff's current law portion. Only thing you have to do, you have to apply Kirchhoff's voltage law and solve the problem. Now before I start, I just want to have a look into this, and if you are watching this seriously, draw this circuit diagram in your notebook first, then we will start solving it. This is little complicated problem. Sir, I didn't. I got it, the KCET practice paper in the mail. Okay, you didn't get the practice paper. Okay, I will check, Sagar, why you did not get. I will inform. Please wait till Monday. If you have if you have registered it, you should get it. Okay, there was a glitch happening yesterday. Maybe that glitch was there. When did you register, by the way, Sagar? If you tell me, I will be able to help you. If you did it yesterday, definitely you will get it. If you are doing it now, I will try, but no guarantees. If you did it yesterday before 12 AM as mentioned during the live, then definitely you will get the PDF. Okay, Sagar. Now, so let's see the circuit. Here we have current I1 passing through this 10, I2 through this 5, then we have this I1 minus Ig through this 20 and I2 plus Ig through this 15. First test is whether this Wheatstone bridge is balanced or not. If you find that this circuit is balanced, then the problem can be solved like this. But if the circuit is not balanced, then you have to do some other method. You have to find, by the way, Ig. Very important to remember, you are trying to find Ig. So 10 by 20 is half, and 5 by 15 is 1/3. That means these two ratios are not same. That means this bridge is not balanced at all. So this is an imbalanced or unbalanced Wheatstone bridge. So how to tackle this kind of question? So we will be basically considering loops, and we will also try to consider minimum loops. In case of Wheatstone bridge derivation, we generally take this loop and this loop, but these two loops will not help you to solve any unbalanced Wheatstone bridge. You have to have a loop where this battery voltage is involved. Okay, this loop will give you some equation, this loop will give you some equation, but eventually you will see that these two equations will be almost same, in fact same. So we will take one of these loops, and another one we will take the loop where this battery is involved, either this below one or the top one. Any one of the loops you can take. Okay, any one of this loop you have to take. So one loop must have battery in case of unbalanced Wheatstone bridge. So first we will take the triangular loop A B D A. So A B D A is our first loop. So what we get from this loop? 10 into I1, then we are going through this 10 into Ig. Now galvanometer resistance is given here 10, so 10 into Ig, and we are going, if you see that we are going in the direction of current throughout up to this point, so it will also be plus, so 10 Ig. Now when we are going from D to A, we are going opposite direction of the current. Opposite direction of the current means it will be minus 5 I2, that is equals to 0. Okay, that is equals to 0. So this is our first stage, first solution that we have done. Okay, so now here we have I1, I2 and Ig, three variables, and also we can see that 5 is common amongst them. So 5 we will take common. We will write 2I1 plus 2Ig minus I2 equals to 0. Okay, there is no cell involved here, that's why we have put it equals to 0. And next we will use the bottom loop. As I mentioned, I will use the bottom loop, that is ADCEA. Okay, ADCEA. So this loop passes through the cell. Okay, this loop passes through the cell. Okay, and if required we might need to use the top loop as well, but I will try to solve it using the bottom loop only. Okay, now what is, by the way, I? Here I is I1 plus I2, as simple as that, because I1 and I2 going out, I is coming in, that means I is equals to I1 plus I2. That is obvious. Okay, now we will use this loop and we will see what is the equation. So I2, we are starting here, I2 into 5 or 5I2. Now when we are going from D to C, again we are going in the direction of current, so 15 into I2 plus Ig. And that should be equals to our EMF, because we are going in the direction of the EMF itself. Okay, so that should be equals to E, that is 10 volt. Okay, Sagar, as I mentioned, if you have done it yesterday, definitely you will get your question paper. Worry not. It is my responsibility to make sure that you are getting your question paper. But as you know, our office is closed. Only I am here taking this live lecture. Monday, first hour, I will request the team to check it, and you should get your get that in email. So Monday, after you come back from your college, you will get the question paper back in your email. Okay, promise. So now we will see that. So I actually was not even required to solve this question anyway. So 5I2 plus 15I2 plus 15IG equals to 10. Again, everything can be divided by 5, so we will do that. So I2 plus 3I2 plus 3IG equals to 2. So we got 4I2 plus 3IG equals to 2. So this is our second equation. Now as you can see here, we have three variables, I1, I2 and IG. Even though we are trying to find IG, okay, we have three variables in total. So we cannot solve it only using three variables and two equations. So we need to have one more equation, and that equation we will take the top portion of the circuit. Okay, so we will use A, B, C, E, A. So A, B, C, A, B, C, E, A. So this loop is also important. Okay, I thought I could have solved it using the bottom loop, but anyway you have to use the top loop as well. Again, 10I1, again we are going in the direction of current, so plus 20I1 minus IG is equals to 10. Okay, 10I1 plus 20 I1 minus IG equals to 10. Now everything is multiplier of 10, so we can divide everything by 10. We get I1 plus 2I1 minus 2IG equals to 1. Okay, so 3I1 minus 2IG equals to 1. So these are the three equations that we have got. Now we have to use these three equations to solve the equation. So let me write the equations one by one. 2I1 plus 2IG minus I2 equals to 0. Then we got 4I2 plus 3IG equals to 2. 4I2 plus 3IG equals to 2, and 3I1 minus 2IG equals to 1. 3I1 minus 2IG equals to 1. So these are our three equations, and we will try to solve IG from these two equations. Okay, so the easiest way to find the relationship between I1 and I2 and put it in one of the equations and simplify it, because we can eliminate IG from these two equations. Or there is one more way you can do, is that find the relationship between I1 and I2 and find Ig in terms of I1 and I2. We put it in these two equations, simplify I1 and I2, and then you can calculate Ig. So what I will be doing, I will take, this is 1, this is 2, and this is 3. So what I will do, I will solve a relationship between I2 and I1 by eliminating Ig and use that relation again in the top equation to solve it. Okay. So first we have to do Ig we are eliminating, so multiply 2 with 2 and then add it with 3 after multiplying it with 3. So 2 into 2 is 8 I2 plus 6 Ig equals to 4, and 9 I1 minus 6 Ig equals to 3. Add them, you get Ig cancels, 8 I2 plus 9 I1 equals to 7. Okay, so this is the relationship between I1 and I2. So as you can see that obviously the relationship is not pretty. I1 is equals to 7 by 7 minus 8 I2 by 9. Okay, so 7 minus 8 I2 divided by 9 is I1. Now we will use this I1 value in this top equation. This equation we have not yet used, so you will use this in this top equation, and we got 2 into 7 minus 8 I2 divided by 9 plus 2 Ig minus I2 equals to 0. One good thing about the top equation is that right hand side is 0. So now multiply every number with 9 so that this 9 can be removed. We get 2 into 7 minus 8 I2 plus 9 into 2 is 18 Ig minus 9 into 1 is 9 I2 equals to 0. Now simplify. 14 minus 16 I2 plus 18 Ig minus 9 I2 equals to 0. So now we got 18 Ig minus 25 I2 equals to minus 14. Okay, this is our equation number 4. Now we have two variables and two equations. So if you see that equation number 2 and equation number 4 both contains Ig and I2. So that's how we can solve it. So how to solve it? We multiply equation number 2 with 25 and equation number 4 with 4 so that we can eliminate it, right? So multiplying 2 with 25 and multiplying 4 with 4. Let's see. So 25 into 4 is 100 I2 plus 3 into 25 75 Ig equals to 2 into 25 is 50. Okay, and here we have 4 into 18 is 40, 32, 70, 72 Ig plus, and 4 into 25 is minus 100 I2. So we just rearrange it, and that is equals to 4 minus 14 into 4, that is 40 plus 16 minus 56. Okay, so you get this cancelled and you get 147. So 147 Ig equals to minus 6, or Ig equals to minus 6 by 147. So the answer can be little complicated, but also problem is little long. But if you practice this problem, it does not take more than 10 minutes to solve a question. I solve it under 10 minutes, and frankly speaking, I just found this question, I picked it up, and I have not even practiced it. Okay, I only followed the procedure and I got this answer. So what are the procedure? First of all, check whether the bridge is balanced or not. Here it is not balanced, and first you have to consider one of the triangular loop, and second you have to consider the loops with batteries. With the loops with battery, both the loops you have to consider. Okay, otherwise you will not be able to solve this question. Okay. So this is the process, and one thing in circuit theory related problems that you might be not sure whether your calculations, your answers are correct or wrong, because it is a trend in your PU board, the final answer is not pretty. Okay. Hi Ganesh. Sir, can I take print of the KCET practice paper? Yes, you can take print. It will be given to you as a PDF. You can download it. You can store it in your laptop, in your mobile phone. You can use it as you like. Okay, no problem whether you want to take download or you want to print it. Solutions are also given at the end, but I will suggest that don't look into the solution at the first. Try to solve it, at least see how many questions you can solve without any preparation. Okay. Now there is one more question. I will give this as homework to you. Try to solve this question as a homework problem for all of you. Okay, so take a screenshot if you want. This is from your previous year model question paper. Answers are again not pretty. This is also a Wheatstone bridge problem, as you can see, 10, 20, 10, 5. And again it is not balanced condition. 5 ohm is passing through this, I1, I2. Battery voltage is not given, but the total current is given here. So this might be slightly easier. Okay, so that means from this you can say that I1 plus I2 equals to 1 ampere. That is given. So this will be slightly easier problem than the previous one. Previous one is from your previous board paper. This one is from your model question paper. Okay, this is also a Wheatstone bridge. Even though it looks like a rectangle, this is also a Wheatstone bridge. 10, 10, 20 by 5. So not balanced. 10 by 10 is 1. 20 by 5 is 4. So definitely not a balanced Wheatstone bridge. This is a 5 ohm resistance passing through this. And as you can see, current I1 is going here, I2 is going here. And they asked you what is the value of I3. I3 you have to calculate. Now we will solve. I think I had one more question. Okay, maybe I missed that. Oh, no. Okay, I thought I had one more question, then I will solve this question as well. No homework, so enjoy. So we have this is the last question of the day. We have a 10 ohm resistance here, 10 ohm resistance over here, 5 ohm resistance over here. Current I1 plus I2 equals to 1 ohm is given. So we will first we will take this loop. We will take this loop. Because it is given, we can take only these two loops. Voltage value is not given, so we do not need to take any other loops. So these two loops are sufficient. So we will take the first loop and say A, B, C, D, E, F, G. So first we will take the loop A, B, C, F, G, A. A, B, C, F, G, A. So if you see that the way to write the name of a loop is your starting point and your ending point are same. So this is a way of writing the name of a loop. So if you write something like this, that means it is not a random thing, it is a name of a loop. Okay, A, B, C. So you are not doing some typing practice. Okay, you might thinking that, sir, what is this ABG? So when we are kid, computer just came and we have the keyboard, we used to type random things, and it might look like those random letters that you might have typed. Okay, nowadays you are all expert in computers, right? You can teach me sometime. So this is not a random typing, it is just the name of the loop. Okay, so first we will see what is the first resistance. First resistance is 10. What is the current through 10? Current through 10 is I1. So 10 I1, and current through next part of the circuit is C2F, and C2F again we are going in the direction of current, and this is 5 into I3. So it will be plus 5 I3. Second part, last part, we are going in this direction, FGA. So when you are going from FGA, you will see that we are going in the opposite to the conventional direction of current. That means this will be negative. So minus 20 I2. This will be equals to 0. No batteries are there in particular this loop. Now we'll also use this simplification. Everything is divisible by 5. So after you construct the equation, you check if there is a common factor or not. If common factor is there, divide it. That will simplify the problem. So common factor is 5 over here. So we will divide it. We will get 2I1 plus I3 minus 4I2 equals to 0. Now we will use this equation. So from here we can say that I2 equals to 1 minus I1. So we will use this in this case. So 2I1 plus I3 minus 4 into 1 minus I1, that is equals to 0. So we got 2I1 plus I3 minus 4 plus 4I1 equals to 0. So we got 6I1 plus I3 equals to 4. Okay, so this minus was go to the other side and becomes 4. So this is our equation number 1. Now we will take the other half of the loop, that is C, D, E, F, C. C, D, E, F, C. And as we are going in this direction, we are going in the direction of the current. Current is I1 minus I3. So I1 minus I3 into 10. So 10 into I1 minus I3. Okay. Next we are going through this loop. Now this loop, when you are going from D to E to F, you see that we are going in the opposite direction of the current. So opposite direction of the current means minus 5 I2 plus I3. Okay, and when we are going from F to C, we are going again in the opposite direction of the current. That means it will also be minus 5 I3, that is equals to 0. Again common factor is 5, so we will divide everything with 5. We get 2I1 minus 2I3 minus I2 minus I3 minus I3 equals to 0. So all the 5's are gone, and this after you divide 10 by 5, you got 2, so 2 is multiplied. Now what is the equation? Final equation, only one I1, that is 2I1 minus only one I2 and 2, 3, 4 minus 4 I3, and that is equals to 0. Okay, so this is the second equation. Now second equation, again we have to put this value instead of I2, so we get 2I1 minus 1 minus I1 minus 4 I3 equals to 0, or 2I1 minus 1 plus I1 minus 4 I3 equals to 0, or 3I1 minus 4 I3 equals to 1. So this is our equation number 2. So we got equation 1 and equation 2. We have to simplify this. So equation number 1 was 6I1 plus I3 equals to 4. And equation number 2 was 3I1 minus 4I3 equals to 1, right? Equals to 1. Now, how to simplify this? Obviously, we want to eliminate I1 because I3 we are looking to find. So we will multiply this equation by 2 and then we will subtract. So 6I1 plus I3 equals to 4. 6I1 minus 4I3 4 to the 8. So make sure you are following the all correct process. 4 into 2 is 8I3 equals to 2. Now we have to subtract. So plus minus, okay, this cancels, we get 9I3 equals to 2, or I3 equals to 2 by 9. So this is much simpler problem only because I1 plus I2 equals to 1 ampere is given. Sir, there is a shortcut for this problem for KCET. Which problem? Sagar is saying, can I do B Pharma? B Pharma, you have to have PCMB. I think PCB you can appear and you can do B Pharma. But nowadays pharmaceuticals is not a very good highly prospecting, you do not have highly prospecting career opportunities in B Pharma. Yeah, not a bad option if you want to do research in medicine and all, but you have to be very, very dedicated in that. Then only you can do B Pharma. Okay. Ganesh, which question you are saying there is a shortcut for KCET? Okay, Sagar is saying, I got the KCET practice paper, congratulations. This question you are saying there is a shortcut for KCET. What shortcut you want to use? Please tell me that shortcut that you want to use. I have used shortcut. There is no shortcut for unbalanced Wheatstone circuit. Okay, the shortcut is only for balanced Wheatstone bridge that I have already used and I have already solved. Okay, but for unbalanced circuit there is no shortcut. You have to use circuit analysis and simplify it. Okay, I hope that clears your doubt. No shortcut. These are unbalanced Wheatstone bridges. They are not balanced Wheatstone bridges. For balanced Wheatstone bridge, there is shortcut that I have already showed it to you, right? And if you have any other doubt, please let me know. I can discuss. Otherwise, I will close this live chat. In between, Tanmay came and asking ray optics KCET. Ray optics, Tanmay, we will obviously do ray optics. Okay, so I hope you enjoyed today's session, and if you have any more doubts, any questions, any comments, please mention that in the comment below. Also, if you want more papers, please subscribe to our WhatsApp channel. We do some exceptional stuff from time to time. So if you have not yet joined our WhatsApp channel, please don't forget to join the WhatsApp channel. And if you have not yet subscribed, this is, I know those who are talking here are subscribed, because only subscribers can talk over here. Okay, so with this note, I'd like to close this lecture, and all the doubts that you might have, please mention in the comment section below.